Well, hey guys, thanks for joining me today in science. Hey, we're just going to do a few notes on this new topic that's just basically called balancing polyatomic ions, which is what this big word here is. And if you haven't finished the homework from last week, which is balancing ionic compounds right here, you're going to need to learn how to do that first before you'll have any idea of how to do this particular piece. So if you finished all of your homework from last week and you handed in that sheet of just balancing chemical equations, then you'll be able to do this particular sheet right here. So what we have here is, if you look at this table, you're just going to notice that there's a whole bunch of ions that have two or more ions attached to them. So like NH3, NH4, HCO3. And you'll notice too that when you look at them carefully, that they all have their charges on the top. So I'm just circling them right now, -3, -2, -1. So it's a lot like what we did last week, where everything has its own charge. And all of these guys, you'll notice, are negatives. So they all go with a metal. The metal will go first, and then these guys will go second. So just making sure that you kind of can see that there's charges there and that there's a whole bunch of letters that are connected. And that's just how these guys occur in nature. And so when you want to put like a metal and one of these guys together, like say calcium and chlorate, you can put them together and you need to use this symbol, not chlorine, chlorate. So that just brings me down to the notes here, and we'll just kind of zip through them and you'll be able to do the next piece of your homework. So polyatomic ions are ions that consist of more than one atom. And so that means that there's going to be a lot of them. So like I said, NO3, that actually has 4 atoms, 1 nitrogen and 3 oxygens. Or if you look here, PO4, 3 minus, again, you have one phosphorus and 4 oxygens, so there's 5 things there. And you'll just notice that they're kind of grouped together, and there's like 2 letters kind of stuck together with some numbers there. So just remembering from last week, ionic compounds, they always end in IDE. Okay, so like calcium chloride, sodium phosphide, potassium iodide. And that's what we did last week when we were looking at metals and nonmetals. Super easy. Well, this week is basically the same. The only difference is that the polyatomic ion table that I gave you above does not end in "ide." All of these things in this table end in "ate" or "ite," chlorate, permanganate, and this one happens to be an "ide," but that's just because it's oxygen. Phosphate, silicate, sulfite, and stuff like that. So polyatomic ions do not end in "ide," they end in different letters like ATE, calcium nitrate, sodium sulfite, potassium permanganate. And you'll notice that they actually, when you look at them over here, that they have a lot of letters and numbers that go along with them. So they look like more complicated formulas. In the end, they're actually really not. But that's what we're going to be looking at and looking how to balance today. So guys, balancing works the exact same as it did last week as ionic compounds. You're always going to, number 1, make a chart. Easy peasy. Number 2, you're always going to draw the charges. 3, you're going to balance out the packages. But the new thing today is that you're going to have to add brackets if they're needed. For instance, in this particular formula, they're needed because this is calcium, and NO3, if we go up to this chart and we find it, let's see if we can find it, NO3 right here, is nitrate. So it has a charge of -1. Going back down here, calcium has a charge of +2, and nitrate, NO3, has a charge of -1. You'll notice that this guy right here needs another package to balance. So what's important about that is that you'll see here that we need to use brackets around the NO3 to indicate that you need 2 packages of this particular substance. So you need to use brackets kind of like in math to indicate that that 2 is indicating to all of this. This is 1 package. So NO3 is a package, and you need to indicate how many you used. So why do we use brackets? So here we go. So this is why right here, calcium nitrate, NO3. So the same thing I did here. I made my packages. I drew out my nice little diagram as I did last week. And I asked myself who needed more, and it was NO3. Nitrate needed more. How many? Well, they need 2. So that's why I put this 2 just below the brackets here. All right? And so that's just indicating that we needed 2 packages of NO3. Since nitrate needs 2, we need to add brackets to make sure that all of the NO3 gets 2. And there we go. We can't write it like NO3 and then a 2 because basically that says that we're needing like 32 oxygens, and that is not what we need. See how this is? You can't write it like that. So that's why you have to put these brackets in to make sure that you kind of designate that there's needing to be 2 nitrates and not 32 oxygens. We add brackets to make sure all of the polyatomic ions gets balanced. So right here, I just want to show you, I did some practices. And so here's the first one, magnesium chlorite. So in order to find chlorite, you have to notice that it does not end in IDE. So you cannot go to your normal periodic table. You need to go to this table and find it. So we have to find chlorite on this table, and here it is. We got to remember that if it was chloride, IDE, we would be able to find on the periodic table, but ite is only found on this polyatomic ion table. So it's CiO2 and there's a -1. So when we come back to our practice problems down here, that's why we wrote this right here. So it comes in packages of -1. Well, who needs more here? Well, it happens to be this chlorite. It doesn't have enough to balance. It needs another one to balance those two. And so what happens is down here, you write the metal first like you did last week, and in brackets, you put this because you need 2 of them. So that's how we indicate that 2 packages of this are needed. We use brackets. If we look at this particular chart, we're looking at gallium and oxalate. Again, this doesn't end in "ide." If it ended in "ide," we could find it on the periodic table, but we can't. We have to find oxalate on the polyatomic ion table that I've provided for you, and it happens to be C2O4 with 2-. And hey, look at this. This guy has 3, and this guy has 2. And so whenever we have a 3 and a 2, we remember that we do the flippy-do, and that the gallium gives the 3 to this guy, and that this 2 is going to go to the bottom of gallium, just like it has down here. You'll notice that we flipped the charges, so we gave gallium 2, and we gave this oxalate 3. But remember that we have to put the oxalate in brackets because we have to designate that there are 3 packages of that are needed to balance gallium. The last table here is lithium nitrate. Again, it's not nitride. That would be found on the periodic table. But ATE is found on the polyatomic ion table. So we notice that its charge is -1 and that lithium's charge is +1. And guess what, guys? It's balanced. So this needs no brackets or no numbers. It's just lithium, LiNO3. Just simply write it through like that because it doesn't need any numbers. So guys, that's how we're doing this particular stuff. And you're just going to have to use the new and improved polyatomic ion table. If you are interested, there actually is a polyatomic ion table on your yellow periodic table, but it's really tiny, as in like it's so hard to read. So that's why I've provided one for you in the notes. You might just want to use that one when you're doing your homework this week, but know that there is one just at the very top above the metals in your yellow periodic table. I'll show you what's expected here for this particular practice, and then I'm going to get you to pause the video just as normal. You're going to pause it, you're going to do the work on it, make sure that you complete all of these by yourself. After you complete all of them by yourself, you can check your answers, see if you got them right, and we'll go from there. So what you're going to do first is you're going to have to make a chart. So sodium carbonate, remembering that 8 comes from the polyatomic ion table, and when I looked, I noticed it was CO3 and 2-. So here we have it just like this. So when we write the chemical formula, we realize that sodium needs more. It needs 2 altogether. So the answer here is Na2 and then CO3. Now, we didn't need to do any brackets because CO3 didn't need any extra, but sodium did. But sodium doesn't have any extra convoluted numbers, so you can just write it like that. All right, and then that's how we go. Scandium hydroxide. Okay, so scandium is Sc, and oh, sorry, actually, you know what? You guys need to pause it now. You need to do it by yourself. Pause it, do it, make it happen. Make sure that you can push through this by yourself. Make sure that you're getting it. Come back to the answers after. Okay, so I'm going to do the rest of the worksheet, but give it a pause for yourself. Write these down. Get them all right. Go for the glory. And I'll just go like this so that you can actually see it. Pause it here. Do them all right now. And I'm going to do the answers. All right, here we go. So scandium, Sc, and it looks like it's 3 pluses. Okay, hydroxide is OH and it's a minus, so if we look like that, that's how we're going to go. We recognize that hydroxide is the one that needs more. It needs 3 altogether, so it's scandium, and I need to use brackets. I need 3 packages of OH to balance scandium's 1. Lithium borate. Borate is BO3, I believe. Oh, I have to just take a look because my periodic table is so bad. Borate, PO3, and 3 minus, okay? BO3 and 3 minus. Lithium is 1 plus. I notice that lithium's the one lacking. It needs 3, so lithium 3, BO3. No brackets needed because borate happens to have more. Iron 2 sulfite. Remembering from last week that means that we use Fe2 plus here because it tells us right here that this is the 2 plus. Sulfite is SO3, I believe. Let's check. Sulfite is SO3 2 minus. Okay, so SO3 2 minus. Looks like it's balanced, so I don't need to do anything. And I'm done. Nickel 3. This means 3 plus. So it has 3 pluses here. Cyanide. Cyanide is SN, or CN, sorry, with a minus. So I notice here that CN is the one that's lacking. It needs 3 to balance. So it's nickel, and then it's CN in brackets, and I need 3 packages of it to balance. All right, these last 3, I need to check to see if there's more than one form. So that's why you have this chart right here that says Roman numeral. So you just want to make sure, okay, does it need a Roman numeral or not? So when I go and look at barium, Ba, I need to find it because that's one I can't find really fast for some reason. Okay, barium 2 plus. So it only has a 2 plus, so it does not need a Roman numeral. It's just 2 plus. Okay, and then C2O4. Okay, I have to find that on my chart. C2O4. So I'm looking, C2O4, C2, there it is, oxalate. And it has a minus 2. Okay, sorry, C2O4. Okay, it looks like it's balanced. Yeah, cool, cool. And so this is barium oxalate. We don't change anything when it comes to polyatomic ion names. We just call it barium oxalate. Au. So it looks like gold does have 2 forms. So yes, it's going to need a Roman numeral. Okay, gold has 2 forms. The first form is 3 plus, and the second form is just a plus. So we're not sure which one we used yet, but we'll find out in a second. And we paired it with CrO4. I think. Let's go look. Maybe I made a typo. Nope. Looks like that's chromate with 2 minus. Chromate with 2 minus. Which one did we use? Looks like we gave oxygen, sorry, I gave a gold 2. So it looks like we had to use this one because it needed to have 2 to balance. So what we used was we used gold 1. And then I said that this was, oh no, I can't remember. Chromate? Yeah, chromate. Okay, don't change the ending because it already has the funny ending. And then this one is cobalt, CO. And then if I look at cobalt, I notice, oh yeah, it does need a Roman numeral as well because it has 2 forms. It has a 2 plus and a 3 plus. Okay. All right. And then PO4, if I just go up here and find my PO4, has 3 minus. So 3 minus. Okay, which one did we use? Do we need, well, it looks like they got numbers, a 3 and a 2. So it looks like they had to do the flippy-do. So it looks like we had to use cobalt 2. So we're going to write cobalt 2. And and then that was, oh no, phosphate. Cool. And that's just basically, so if you guys are just looking at your answers, there they are. So hopefully you can actually now proceed to writing all the chemical ionic compound formulas that there ever was in the whole wide world. This means that you now can pretty much do any worksheet anywhere from grade 9 through to grade 12 on this particular subject. So guys, I really hope that you pursue the homework for this week just to really excel in this, and there's going to be a bunch of worksheets up there, so do your best to just complete them, and yeah, and I will see you next week when we do molecular compound balancing.